Hello class, today we are going to go over section 5.2 logarithmic functions and properties of logarithms. Now, our objectives are to apply logarithmic properties. So we need to look at the properties, the basic properties of logarithms for b greater than 0 and b not equal to 1. Property number 1 says the log base b of b equals 1. Okay, and now I'm just going to kind of show you and prove it to you over here at the right that this kind of makes sense to be a property of logarithms. So if we convert this logarithmic form to exponential form, converted to exponential form is b to the first equals b. And we know that anything to the first power equals itself. So it's easy to see that this logarithm here, this logarithmic property holds. Second property is log base b of 1 equals 0. It's easy to see that this one holds because b to the 0 equals 1. Anything to the 0 equals 1. So that's why that logarithmic property holds. Property number 3, log base b of b to the x equals x. That one holds because b to the x does equal b to the x, converting it from a logarithmic form to an exponential form. And then here, log or b raised to the log base b of x equals x. If I convert this to logarithmic form, then it essentially just is the log base b of x equals the log base b of x, which is obviously true because they're both the same thing. So essentially here, the b and the log base b cancel each other out. You're left with the x. Property number 5 also states for positive real numbers m and n, if m equals n, then the log base b of m equals the log base b of n. So essentially you can't take the log of a number and it give you two solutions. The log base b of m is always the log base b of m, even if you change the number to a different letter here. If it's the same number, it's the same logarithm. A few additional properties here for b greater than 0, b not equal to 1, k a real number, and m and n positive real numbers. If we have the log base b of m times n, we can break that up into the log base b of m plus the log base b of n. So multiplication we can break up into two separate additions here. And then log base b of m over n equals the log base b of m minus the log base b of n. Okay, now here we're breaking this division on the inside up to a subtraction on the outside. Last property here, log base b of m to the k equals k times the log base b of m. Okay, all we've done here is bring our exponent out to the front. That property holds as well. So let's look at some examples. Example 1 says to write as a sum or difference out using exponents. So let's see if we can go through this here. Okay. Now we have the log base 3 of 6 times x squared times y to the third. Now we have multiplications going on here. So in order to split up these multiplications, I can turn each of these into an addition. So this is the log base 3 of 6 plus the log base 3 of x squared plus the log base 3 of y to the third. Now we also don't want to use exponents here. So we need to come back in here. First one doesn't use exponents, so I can leave it alone. Log base 3 of 6. But the second one, I'm going to bring the 2 in this exponent forward. It'll be 2 times the log base 3 of x. And then for the y here, since it's to the third power, I'm going to bring the 3 forward and convert it into 3 times the log base 3 of y. And now we have expanded this logarithm and turned it into additions, and we have no exponents to worry about here. Okay, if we could simplify the log base 3 of 6, we would, but here it doesn't simplify down to a nice, neat solution. It doesn't simplify down to a whole number or anything. So we're just going to leave it in that log form. Now let's look at part B. The log of x to the 7th times y to the 5th over z to the 4th. Okay, we're going to convert this into the sum and difference of logarithms with no exponents. The two top numbers here, the x and the y, to their respective exponents are going to be added. The z is going to be subtracted. So we're going to convert this to log of x to the 7th plus log of y to the 5th minus log of z to the 4th. The next step, we need to take care of these exponents. So I'm going to bring the 7 forward here. I'm going to have 7 log x plus 5 log y minus 4 log z. And I'm done with part B. Now this example says the natural log of x to the 5th over y squared times z to the 8th. We want to convert that to a sum or difference without exponents. Okay, still holds with natural log just like it would a regular log. So we're going to break this into the log, or the natural log here, of x to the 5th minus, then I'm going to subtract the two bottom terms here. So minus the natural log of y squared, and then minus the natural log of z to the 8th. Okay. Now I need to take care of these exponents. So I'm going to bring the 5 forward. Here I have 5 natural log of x minus 2 natural log y minus 8 natural log z. That's simple. The ones on the bottom get minuses, the one on the top get plus. Okay. Then we're led to B right here. B says the log base 2 of w to the 2/3 times x to the 4th over y to the 3rd times z. Okay, in the denominator. We will do log base 2 of w to the 2/3 plus log base 2 of x to the 4th minus log base 2 of y to the 3rd minus log base 2 of z. Okay, now I need to bring the exponents forward. Even though my exponent here is a fraction, I can still bring it to the front. So I'm looking at 2/3 log base 2 of w plus 4 log base 2 of x minus 3 log base 2 of y. And then I don't have to bring anything forward for the log z, so I'm doing log base 2 of z here, leaving it alone. That would be my final answer. Now let's look at handling the radicals here. So we had a fractional exponent in the last one, but let's look at the radical itself. It says write as a sum or difference without using exponents. Here we have the natural log of the 5th root of x to the 3rd over y squared z. Okay, so what I would do first if it was me, okay, this 5th root is the same as raising this the 1/5 power. So the first thing that I would do is I would pull the 1/5 out to the front and then rewrite this as the natural log of x to the 3rd over y squared z. Now that 1/5 has to go to everything. So we have to keep it with everything as we're working through our problem here. So I'm going to go 1/5 natural log of x to the 3rd minus 1/5 natural log of y squared minus 1/5 the natural log of z. Okay, then I can get rid of my exponents here. So I can bring the 3 forward, and now it's going to look like 3/5 natural log x minus 2/5 natural log y minus 1/5 natural log z. So something that looks really complicated here, when we simplify it out, didn't really turn out to be that overly complicated. Now, let's evaluate using properties. So an example for it says given log base b of 2 equals 0.63 and log base b of 5 equals 1.46, let's evaluate the log base b of 40. Okay. Now, they're not looking for you to try to figure out what b is here. They're looking for you to use both this, and then use a substitution for these when you're able to get it in terms of 2 and 5, or 2 or 5. Now, if we look at the number 40, the number 40 can be broken up here into numbers that are divisible by 5 and 2. If you note here that 40 is just 8 times 5, right? That'll help us use a log base 5. And because these are multiplied here, I can change it to log base 2 of 8 plus log base 2 of 5. Now I can substitute that 1.46 value in for this log base 2 of 5 when I'm ready. But I still don't have this in terms of 2. But what do I know about 8? Well, 8 is just 2 to the third power. So 2 times 2 is 4 times 2 is 8. So I could rewrite this as the log base 2 of 2 to the third power plus the log base 2 of 5. Then I could use my exponential property here to bring that 3 to the front, and now I have 3 log base 2 of 2 plus the log base 2 of 5. Lastly, I'll do 3 times 0.63 plus 1.46. I'll do my substitutions of those respective values in here so that I can get an estimate here for the log base b of 40. Now, all you have to do at this point is use your calculator to solve what that would be. So let me see if I can pull my calculator up real quick. And hopefully you can go ahead and type that number in instead of having to even wait for me at this point. But we'll let my calculator load. And as soon as it does, if it does, there it goes. We will type in 3 times 6.3 times 0.63 plus 1.46, I believe. I believe we're looking at 3.35. So that would be our answer. Part A. Now for part B, I'm looking at the log base b of 25 times b to the third power. I'm going to go ahead and break this up into two logarithms. It'll be the log base b of 25 plus the log base b of b to the third power. Now, let's focus on the log base b of 25. We obviously know that 5 goes into 25, and 5 squared is 25. So I'm going to replace that 25 with 5 squared. Okay, and then I still have the log base b of b to the third here. Okay, now I'm obviously going to replace the log base b of 5 with 1.46. So it'll be 1.46 squared, or sorry, see, I messed up a property here. I hope y'all were yelling at me on the screen. It's not squared, right? Got to use, so don't rush it, Mr. Shives. Got to use our other property here and bring that exponent forward. Let's do that. So we've got 2 times the log base b of 5 plus the log base b of b to the third. Don't get ahead of yourself. So now we have 2 times 1.46. That's more like it. Now, we do have a property here. One of the initial properties we went over at the very beginning of the lecture says that the log base b of b is what? Now, if you can't remember it, you can always convert it to an exponential form here and say, okay, log base b of b to the third equals what? Well, that means that b to the what equals b to the third. Obviously, this should be 3. Okay, log base b of b cancels itself out. You're left with whatever exponent you have. Okay, now all we have to do is type in our calculator 2 times 1.46 plus 3. 2 times 1.46 plus 3. We got 5.92. And we have our answer there. Let's look at example 5. It says the same thing. Given log base b of 2 equals 0.63 and log base b of 5 equals 1.46. Let's evaluate the log base b of 1 over 10. Okay. Well, I'm going to go ahead and break this into a subtraction. I've got the log base b of 1 minus the log base b of 10. Hopefully your properties are screaming at you right now that, hey, the log base b of 1 is just 0. So I have 0 minus the log base b of 10. Okay. Also, looking to break it up into a 2 and a 5. 10's a really easy one to break up. Got the log base b of 2 times 5, because that's the same thing as 10, which I can then break up into the log base b of 2 plus the log base b 5, and then substitute their respective values. 0.63 plus 1.46, and I can use my calculator to add those two things together. 0.63 plus 1.46, looking at 2.09. Good to go on part A. Let's try part B here. Okay, I'm going to break this up. Say, okay, this is the log base B of B minus the log base B of 50. The log base B of B, that should just be 1. Okay, now the log base B of 50, a little more tricky. I need to break this up into 2s and 5s. If I look at 50, I know 5 can go in 50. 5 will go into 50 and give me a 5 and a 10, but that really doesn't help me too much. What else can go into a 50 that's just 5s and 2s? Well, what if I broke the log base B of 50 into 25 times 2? That would allow me to break this up into the log base B of 25 times the log base B, plus the log base B of 2. And 25 is just, and you're going to want to keep this in parentheses. 25 is just 5 squared. So I'm looking at the log base B of 5 squared plus the log base B 2. Okay, well, I can break up that exponent here and bring it to the front. I'll say 2 log base B of 5 minus the log base B of 2. All I did there was make sure also in that step that I distributed the negative that was supposed to go to both of these terms. Okay, now I can just do a substitution. I can do 1 minus 2 times 1.46 minus 0.63. I just have to type that in my calculator. So I'm looking at negative 2.55. Okay. That will be our final answer for part B. Okay. Let's write these expanded logarithms as single logarithms. So here I have 3 log x minus 2 log y minus 5 log z plus 7 log w. And I want to write that as a single logarithm. First thing I got to do is move all these exponents back to their respective terms. Okay. Okay. So it's going to look like the log of x to the third minus the log of y squared minus the log of z to the fifth plus the log of w to the seventh. Now I just have to combine them. Easiest way to do this is the positive are going to be in the numerator. The negatives are going to be in the denominator. So I'm really just looking at the log of x to the third, w to the seventh, over y squared z to the fifth. So I've taken this expanded logarithm now and I've rewritten it as a single logarithm. Let's try it with the natural logs. I have the natural log of x plus 2 plus 3 times the natural log of x. Okay. Now, these are added. I do have to take care of this exponent here, move it back in first. So I'm going to go to the natural log of x plus 2, leave that alone for now, plus the natural log of x to the third power. Now, they have the same base out front, which is the natural log, so I can combine them. So they're added, so I'm going to multiply them. So it's going to look like the natural log of x plus 2 times x to the third power, which if I simplify that by distributing, it should look like the natural log of x to the fourth plus 2 x to the third. And I've simplified that into a single logarithm. All right, so let's try this it says rewrite each of the following expressions as a single logarithm. So here I have the log base 3 of x plus 4 log base 3 of y. Okay, let's see what we could do with it. Oops. So what I'm going to want to do here first is I'm going to want to bring this 4 back as an exponent here. That's exactly what I did in this first step. This is the log base 3 of x plus the log base 3 of y to the 4th. Okay. Now, these are added. So my next step with this is going to be to multiply. So I'm going to convert this down to a log base 3 of x times 4, or y to the 4th. If I look at my second one here, I'm going to have to bring the 1/2 in, and I'm also going to have to bring the 3 in to be exponents before I can combine them to a single logarithm. So I have the log base a to 1/2 minus the log base b to the 3rd. Then, because they're subtracted here, it's going to turn into a division. So as a single logarithm, it'll look like the log of a to the 1/2 over b to the 3rd. The only thing I'll caution you here is if it's a multiple choice, you may also see it as the log, wasn't supposed to write equal to, I was supposed to write parentheses, the log of the square root of a over b to the 3rd. You may also see it in this one, because the a to the 1/2 is the same thing as the square root of a. Now, let's look at this example. It says, rewrite each of the following expressions as a single logarithm. The natural log of 5x minus 3 natural log of z. The first thing that I'm going to do is move the 3 back into an exponent form. So I've got the natural log of 5x minus the natural log of z to the 3rd. Okay, there's a subtraction going on here. So it's going to be a division. So it's going to simplify down to the natural log of 5x over z to the 3rd. Now this completes this particular section. If you have any questions, please don't hesitate to reach out and let me know. Other than that, I will see y'all next time.